Okay, folks, would you pull out those conversion sheets I handed you yesterday? Um, Long story short of this is if we can't get work through these conversions, we're not going to be able to do sprayer calibration very good, so we need to be able to do these conversions. I am going to do my level best with the technology I've got to, sorry, uh, go through this on the board a little bit. If I advance a slide, I apologize. This thing is not what you'd call spectacular, and you're also gonna, if I use a decimal point, it advances a slide, so you're gonna have to use your imagination for decimal points, I'm sorry to say. But okay, so I'm gonna do my best, and hopefully I can save what I scribble in there, and you guys can look at it again if need be. Okay, so um, yeah, this is all pretty basic stuff, and I apologize if I'm going to be boring some of you on this. I could see some of you handed that piece of paper in about 13 seconds, and the rest of you, or some of you, are kind of scratching your head and your butt both. So we're going to try to solve that real quick. So, okay, the first one is we're converting grams to ounces. Okay, so you flip over to the other side of your sheet, and you should have a conversion. Um, and yeah, I already punched some of them in. So 1 ounce equals 28.35 grams. So just by looking at that, can you? A gram is smaller than an ounce, right? So you understand that you're going to have to come up with a smaller number, right? Okay. So there's 900 ways to get at this. The little trick that worked for me was just doing cross multiplication. Does that work for you guys, or does somebody else have something they want to bring forward that works for you? Okay, we're going to do it my way because nobody spoke up really fast. So again, we're going to give this a try here, so see if we can work at it. The way I like to set it up is I go 1 ounce, 1 ounce over 28.38 grams. Is it 3.5? Did I get that wrong? Paul, yeah, my apologies. I certainly did that wrong.
You said it correctly.
Okay. And then that's going to equal our variable, what we're trying to find, x over 3 point, there it went, 5.6. Yeah. Now you just cross multiply, and we do some super simple algebra. I'm talking 6th grade math here. So cross multiply, so 1 times 3.56 equals 28.35. Cool? 28.35x. Yeah. So that's going to equal 3.56. So simple algebra. This is lovely. Then hopefully y'all got a calculator today. $7.96. You're killing me. Cool. Alrighty. Now then I get to go to the next one. Alrighty. Who's gonna, because I'm not gonna do all of this by myself. Jocelyn, you wanna start me on the next one? I looked up and saw you first. Okay. So what Jocelyn's getting at is she's saying, okay, for every pound, I got 453.6 grams. Long story short on this one, you can do this one really, really quick. Just decide that, okay, if I have 2.6 pounds, I need to wind up with a lot of grams, because that conversion right there says there's 453.6 grams to every pound. Super easy way to do this one would be 2.6 times 453. If I could, maybe another year of college and I'll be able to write. Y'all come up with something along the lines of 1179. There I went with the decimal point again. Yeah? Something along those lines? Okay. Alright, now I'm gonna just ask, does anybody need, want to go over 2.7 kilograms to pounds? Really, now's the time. If you got a question, have at it. We're gonna get there. Give me a second. So, did everybody come up with something along the lines of 5.59 pounds for 2.7 kilograms equals 5.95 pounds?
Yeah.
We good? Moving on. Okay. Everybody good on ounces to grams? Give me a yes or no. I come up with 978.06, pretty close to it. If we got, I'm not going to hack anybody for a simple rounding difference. That's not what I'm concerned about. 345 grams should equal about 0.76 pounds. Yeah. Okay. 23 inches is going to come out to 58.42 centimeters. Anybody good? I mean, really, now's the time. 72.6 centimeters should be 28.58 inches. 3.45 meters, 11.32 feet. 2.7 miles equals 14,256 feet. And by the way, everybody probably just ought to have that 5280 put in your head. Another one that ought to just be in your head is 43,560, and that's how many square feet per acre. That's just a number that ought to kind of be in the back of your head. 2.7 miles, yeah, I did that one. 100 feet should be like 0.189 miles. What? Sorry. I have really, really fat fingers. Sorry, my bad. Okay, here's one that we might need to go through. Were people good on this one? I mean, honestly, I mean, can y'all make this conversion between miles per hour and feet per second? This one is going to come up a lot, so we need to go over this one. Alrighty. Okay, so I'm going to ask you all a couple really super simple questions here for a second. How many seconds in a minute? Okay, we're going to write that down. We're going to need that. There is 60 seconds per 1 minute. We're going to need that. All right. How many feet are there in a mile? There is 5,280 feet. Dadgummit. I apologize for that. Bear with me. Yeah. 1 mile. Okay. What other information? So, I'm trying to force you to think, go through this kind of logically for a second. Okay. So what other, how are we going to get there? We're converting how many miles we're going in a given amount of time in hours, and we're converting that to how many feet are you going per second. I think you've probably got about the information that you need, and this is where we're making enough of a conversion that you got to start thinking about crossing off your units so you wind up with feet per second at the end of it. It says we're going 4.7 mph, and actually I should have wrote that differently. Sorry. We're going 4.7 miles in an hour. Right? Okay. So if we just multiply all these, now take a second, and we can start crossing our units off. If we're using division, if you divide one thing by itself, you come up with 1. So 1 times 1 times whatever is whatever. So we can cross miles off. Right? Cool. So we don't have to worry about that unit anymore. Now we just multiply all the way across. So 4.7 miles times 5280. That's giving us how many feet, right? So we've crossed our miles off. So 4.7 distances of 5,280. There you go. $24,816. So basically what we've come up with this point is now I've gone 24,816 feet in 1 hour. Ay. This will test the patience of a saint. Okay, so we're not quite there, but we're getting a little bit closer. At least we've got her down to feet, right? Okay, so I can take that 24,816 down here. Somebody bring a dog in here so I can kick it and feel a little bit better. Multiplied, and now I need to take, okay, if we're asking for feet per second, right? Okay, so we've converted to the feet. We're done there. I had hours, so what have I got to do now? I mean, somebody just stop and logically think about this. What do I need at this point? Okay, we can go to minutes. So now I can just say, hey, there is 1 hour, which is exactly how long it's going to take me to write one little 1 hour over 60 minutes. Yep. I get to cross an hour off. So now I've got 24,816 over 60 minutes. Are we there yet? Not quite. So what do we need to do now? Right, and handy enough, there's 60 of those little suckers in a minute. So 1 minute over 60 seconds. So now I can bring this down one more time. Disregard my dyslexic printing. 60 times 60 is 3,600. There you go. Everybody good? Now then, simple math. You just take 24,816 divided by 3,600. You should come up with something along the lines of 6.89. Everybody saying success on that one? Okay, do I get affirmative head nods? Okay. All right. What was that?
Oh, I just made good notes.
Oh, okay. All righty. So do we want to go through that one? That's just going the exact opposite direction. Y'all wanted it? Okay, let me clean this slide up a little bit. Okay. .4 feet. Per second. Okay, and we eventually want to wind up with miles per hour. Okay. What's another, you guys think logically for me. I think the best way is just kind of think through this. Cassandra, how would you want to start tackling this one? Because I don't want to, everybody's got their own little tricks how they can think logically through this, and maybe you've got the secret there.
Don't you want to get like it like off the
That would be super handy to me. I'm with you, but the thing about it is if I converted 4.4 feet per second to how many miles is 4.4 feet? What I'm getting at is that's a super tiny decimal point, right? So I might be more inclined to get this up into a number that I can wrap my head around. So I would suggest that you actually tackle the seconds part of it and get it up into hours first. So, what do you got, Jordan?
I kind of forgot how to do all these problems, but I think the biggest conversion factor to utilize is when you're changing seconds to hours as opposed to 3,600. That always use over an hour.
Okay, that's exactly where I'm at. So just to restate that for everybody, Cassandra, you're right. We could have got there. But having 17 zeros in front of a number doesn't make any sense to me. So what Jordan said, just to repeat that, is he says, man, let's get out of seconds. That's a very small unit. He says, let's just multiply the 4.4 feet times 3,600. Cool. So we automatically converted 4.4 feet per second into I'm going a bunch of feet per hour. Does that make any sense to y'all? So I like his idea. You have that math handy. What do you get?
4.4 over a second, like you have, and then I do 3,600 over 1
There you go.
hour, and then I go ahead and do another fraction.
Oh, you're jumping ahead and you're doing a bunch of steps. Okay.
1 mile over 52.8.
I like it.
Got 2 ones on the
hold on. I gotta tell all the people on cheap seats on the internet what's going on here. So he wants to go ahead and multiply that and say, okay, there's going to be a mile per hour. We're going to throw that conversion in, so it's going to be 1 over 5280, right? So that 5280 is how many feet per mile? I like it. What else do you want to do, Jordan? Okay, we're just going to multiply here. So you're going to go 4.4 times 3600 times 1. I come up with something about like 15,840. That's going to be feet when I get back to the right slide. Over, we get to cross seconds off. We get to cross feet off. So we're going to wind up with, I got to divide that by 5280. I'm sorry, I was getting ahead of myself. 5280. And I come down to 3 miles an hour. Cool. So all right, now then, so you're not all sitting here looking at me going, what in the Sam hell's going on? What I am preparing you to do is go out and say, okay, how fast does your tractor go? Cody says, I don't know. It depends upon what gear the tractor's in, how many RPM I'm running at. I'm like, you're not helping me any, dude. So what we're going to do is we're going to go out and mark off 100 feet, run the tractor up to how it is for you where it's comfortable to drive, and I'm going to time you and say, how long did it take you to go 100 feet? I can then convert that into miles per hour pretty good. Where we're eventually driving, as you look at the front page of this, you're going to see some pretty cool little formulas there. I need to start figuring out, and now to try to put all this together for you folks. You remember way back when I was asking you to dig through label and I asked you to tell me how many gallons per acre are you putting out? Remember that part? Okay, that's going to get real important again. So XYZ chemical. Paula, if you want to put Tordon out on some CRP, excellent. The label tells you to put 10 gallons out. Okay, well now I got to figure out, so hang with me on this one, Paula. If I got a pump or I got a garden hose, it runs a certain amount of water, right? I can scream and yell at it and say I want more water, but that don't change anything. And really, if the hose is on, it's on. It's going to run that much, right? So if I were spreading that out over 100 feet, so I made you walk along with the end of your hose for 100 feet, do you think it's going to matter how fast you're going, how much water you put out in that 100 feet you went? Right? So if you're walking really, really slow, you're going to put more gallons out. Or if you start trotting with the end of that hose, you're going to put less water out. This is precisely what we're dealing with here. I need to figure out how fast you're going, and then I can actually adjust how much water is coming out of the end of your hose. I can plug a different nozzle in there. So that's what this is. I'm not making you do math just to be a jerk, but this is actually what we're driving at here. So, alrighty. Teaspoons to cups. I think you had to do a couple of conversions in that one. I didn't give you an exact conversion on that one, I don't think. Everybody good on that one? Got like 1.69 cups. Okay. Peyton, you had one you had a question on. What was it? Okay, yeah, that one was kind of designed to be a little bit of a jerk. So, here, let me give you a little bit of let me let you think about that a different way. Peyton, are you a busy individual? Have you got places to go and shit to do today? Yeah, okay. So if I wanted to test and make sure, I'm going to show you tomorrow or the next day this catalog that has literally 30,000 different nozzles in it for 101 different applications and 101 different pumps and all that good stuff. And basically, I'm going to show you how to narrow it down to you have your pick of this 4 or 5 different types of nozzles, but you're putting out a chemical that costs you 120 bucks an acre to put out. Do you think it's to your benefit to go ahead and make sure that, am I putting the right amount of fluid out if I'm going X miles per hour? Okay, now then, back to the original question. Are you a busy person, have places to go, people to see, all that good stuff? Long story short is I got to show you how to test and make sure your nozzles are putting out what they're supposed to. The other thing is for example, I talked about wettable powders. Here, this is what it comes down to. So you run a wettable powder through a spray rig again and again and again. That's a really abrasive material. It's like liquid sandpaper. Eventually, it's going to start wearing out your nozzles. And I come back to this whole notion that, well, if I'm going to be using a $120 an acre application, I want to make sure I'm getting the right amount of stuff out. Obviously, I thought it was worth doing it, but at 120 bucks an acre, I don't want to be pumping any extra out. So I'm going to teach you how to check your nozzles. And this comes back to, Peyton, do you want to stand there with a little beaker catching what comes out of a nozzle for a minute, or do you think we can do it for 15 seconds and then extrapolate out from there? So that one, put quite simply, and you guys might have to bear with me 1 second here. Run down there. All right, so we have 514 milliliters. By the way, did you all know a milliliter precisely equals a cubic centimeter? Just some handy little info. And we're wanting to find out milliliters per 15 seconds. Okay. Alrighty. So if I want to do that, oh, I'm sorry, that's 35 fluid ounces per minute. I didn't type in right. Oh, for the love of Pete. Okay. I'm really not trying to be a jerk about this. All it is 35 divided by 4. So, and here's how I come up with that. I got on the wrong one. Okay, sorry. I'm ready to be where you're at now. Okay, 15 seconds is a quarter of a minute. I mean, you could have, yeah, divide it, yeah. The other way you could do this is take it back to how many milliliters per second. At that point, it would have been 514 divided by 60. Cool. Everybody hanging with me? And then multiply it by 15. Would have got you to the same place. This is just multiplying 514 divided by 4. Nods up and down on that one. It's actually amazing how painful a minute is when you're standing there with a beaker catching stuff coming out of a nozzle for an entire minute. 15 seconds will cut it. Yes, ma'am. So did I. I must have done something wrong. My apologies. I'll go back to that in a second.
Was I wrong? I just took
That's
5 4, 5
correct. That's exactly right. That's a shortcut. What is the math on that one?
128.5.
128.5. Thank you. Okay, everybody okay with gallons to ounces? For all of you cheaters out there that are going to use a unit converter, make sure you're using US units and not metric units on that one. Just a little hint there. And then liters to gallons shouldn't have been a very big deal. Yeah. Okay. I need to go back and do the first one, it sounds like. Yes. I mean, ultimately, the math should look something you should wind up with.
Yeah, except for the ones that are miles over hour, feet over something, most of them I just either break by them and multiply.
Yes, and that's the shortcut, but I wanted to make sure that everybody, if that's how you arrived at your conclusion, great. You're just thinking through it logically instead of crossing your units off. This one should have wound up looking 28, and it's 28.35, isn't it? I typed that in wrong. Good night. Paula, were you at like 0.1256? That, my apologies, I got backwards on that one. Does that look better to everybody? Okay, that's what I had for the day. Thank you. Before everybody runs out, I do want to, so tomorrow I'm going to try doing this again, but we're actually going to start in on going through baby step by baby step, calibrating a spray rig and actually giving you some of the things that you need to know when you start in on that project.